All right, thank you so much. So I got a better greeting into Paris this time than I did last year. Last year I came in on a Saturday, and there was a car on fire at the front door of my hotel, and there was a line of police on one side of the road and a line of rioters on the other side of the protesters on the other side of the road. So that was an unfortunate welcome. So this is much better. So my name is Paul, and I'm a developer advocate at Pivotal, or as my wife would say, I'm a professional vacationer. Which is a little bit true. I'm going to talk about cloud native operations. It's good that we've got a group that is all pretty familiar with Kubernetes and containers, because I don't have to spend most of my time explaining what Kubernetes is and how it works. I can focus on what's important, which is how we're using it, and etc. So I may talk about some tools that are from Pivotal as I go through this, and they're kind of just placeholders for like types of tools. And you can kind of replace any of them with open source tools of your choice. So if I do say like PKS, just think I'm saying Kubernetes and stuff like that, all right? So kind of to get it started, what happened to my clicker? That's better. All right, operations is really the secret sauce to writing good software. If you look at any of the really good progressive like cloud companies, like Google, Netflix, Amazon, etc. They all share this common characteristics. They can take code from like an idea to being written and to running in production in what seems like it's measurable in minutes. So maybe 60 minutes, 120 minutes, maybe even 10 or 20 minutes. And that's not an emergency deploy. That's just how they deploy software. And that ability gives them a competitive advantage in this world where we're all software companies, right? If you can get code into production faster than your competitor, you have an advantage over them. And the more frequently you can deploy software into production, the better your software will be, because you're deploying it in smaller batches. It's easier to fix bugs and get bug patches released, etc. But we do need to move on from like traditional operations. Automation helps get us to this, sure, but codifying your existing practices only speeds up those abilities by so much. There's too much toil, human capital, too many legacy processes built on top of like systems like ITIL, right? They just don't work in this world where we need to be moving a lot faster. So if you have a change control board, if you're doing like deployment windows, you only deploy on a Tuesday night between 3 a.m. and 5, you're probably being beaten by somebody who isn't constrained by those things and is able to release their software faster because of that. There's this survey from Forrester that was just talking about how often are you able to deploy to production. And the average here is still at 3 months, and that is not fast enough. So far, we used to be a year, right? So we've come a long way, but we're stuck at 3 months, a lot of us. And that is because we still have all these legacy business processes in our way. There's less than 10% of people that are doing once a week, let alone the like 2% there that are able to actually release once a day. So we're not where we need to be. And we are being beaten by those 2% that are. And I'm not sure there's an easy way to go from like that old school way of doing things to doing what I'm calling cloud native operations. I think most organizations, especially large organizations, kind of need to go through a process and are somewhere along that process right now. Trying to change everything at once is kind of a recipe for placing this really big bet and having that fail, and then just going back to the old ways that kind of seem like they work. And so I'm going to quickly hit the few key points of such a journey. So this is kind of, we all remember doing waterfall software development, right? Hopefully no one in this room is still quite at this stage of the journey. But there's a lot of companies a lot of big banks, insurance, government agencies that still design software this way. They have years-long backlog of ideas, and it takes years to get an idea through to production, right? Obviously at some point, someone realizes that's not good enough, and we send everyone to Scrum training, and everyone becomes a Scrum Master. And we think that's going to solve all of our problems, and it doesn't quite do so. So we start doing Scrum. We have 2 to 4 week sprint cycles. You have backlogs. You're doing burn charts. You're doing, we're starting to perform those things. And you're often releasing code at the end of that sprint, but you're releasing that to the next team, which is QA, and then to operations. And so you're releasing code every 2 weeks, but it's just sitting in a virtual warehouse, waiting to be tested and to be deployed, because there's still all those business processes around doing that. So the next step is we bring test and QA into, we turn them into developers, right? Because as developers, the way we solve every problem is we just make everyone else look like us as developers. And so we move testing to the left, as we say, and we start doing a lot more unit tests. We start doing integration tests. We install a Jenkins somewhere, and we have that run automated tests for us. And we start doing something that kind of resembles CI, continuous integration. But we still have that wall of processes and stuff between us and getting into production. And this is where a lot of organizations are right now, and they can't seem to figure out how to get through that. Obviously, we move ops into that sprint cycle as well. We rename them DevOps. We give them all like a $50,000 pay rise, and they start writing infrastructure as code, Chef, Puppet, etc., Terraform, whatever. But we don't reduce our deployment cycle by all that much, because we still have that incentive around the business to have zero downtime. We still have ITIL processes. We still do change control. We still have deployment windows. And so we're not releasing code often enough to build trust in our ability to release code. So we're kind of stuck in this this cycle, the opposite of a virtuous cycle. And we just don't trust ourselves to get to that point where we're delivering more frequently. And Chef and Puppet is great, but there's a lot of work that goes into writing those, and there's a whole new set of testing and stuff that you need to do for those. So we can just rub some Kubernetes on it, right? Just rename it DevOpses and call them SREs, and we're on our way to solving that problem. Not so much. You might reduce some of that Chef and Puppet work for an individual app, but you've got this whole new other problem of actually running Kubernetes. In a lot of ways, you'll be adding as many problems as you are solving. And you're still stuck behind that wall. You're actually behind this wall of YAML. Like any app of consequence is going to have hundreds of lines of YAML. And at that point, it gets really hard to read. So again, you're having to do a lot of testing and whatnot. And you're still getting in your own way because of your business structure. You're kind of locked in by Conway's law. So Conway's law, I'm sure most people are familiar with it. But it's basically the idea that the structure of the software that you build is going to resemble the structure of your organization. And not just the software development organization, the whole business, right? And it's not just the structure of your software, but I believe it's also the structure of your infrastructure and how you deploy that software is directly affected by Conway's law. So you kind of need to hack Conway's law and make Conway's law work for you instead of working against you. You need to change the structure of your team, not just your development org, but everyone that's involved in the software delivery lifecycle. You need to change. So we all know this, right? Traditional IT operations, you have a ticket that comes into Jira, a bunch of people work on those tickets via SSH or whatever, and it looks like this. Well, a platform, whether it's like EC2 or Kubernetes or whatever, looks basically the same thing. You've just replaced Jira with an API, and you replace people with software and robots, right? It's exactly the same structure. And so that tells us that our operations team actually is a platform. It's just a really inefficient platform that's made out of meat. And you don't want to be a meat cloud. So if we acknowledge that operations is a platform, then we can treat it in the same way that we treat platforms, as a product. With users, the developers, people wanting to run software, right? So to do this, to build a platform as a product, we build out teams to build and run the platform in the same way we would build out teams to build and run any product. We turn our operations teams into a platform team. And these teams are responsible for building the platform for your application teams to use. And they need to determine at what abstraction layer does it make sense for them to take on building the platform, right? I don't think it's, at this point, very few people should be taking on building the platform at below the IaaS layer. We should all be using one of the clouds, or at least like VMware or OpenStack or something, right? And just like an app team that focuses on specific parts or microservices of a product, we do the same thing for our platform. So we have small teams that build platform services and then contracts for utilizing those services. These services are composed together to create a cohesive platform in the same way that microservices are composed together to create a cohesive application. So teams are multidisciplinary. You have product owners, developers, operations, etc. In all of those teams. And as small teams iterate on a problem, you're going to make lots of small bets and have lots of small wins that accumulate to give you something great, rather than trying to make that one big bet that's going to fail and send you back to doing things your old ways. Hopefully gone are the days where we make billion-dollar infrastructure investments. So as a platform team, you're building up a paved road for your developers to travel on. So as long as they stay on that road, they can expect you to provide infrastructure services such as monitoring and observability, access control, certificate management, stuff like that. And this gives feature teams, product teams, a place to deploy their applications with minimal toil and maximal value. You don't want to be their only choice, but you want to be their best choice for where they're going to deploy their applications. Effectively, you're going to build out code delivery pipelines to take committed source code from development through to production with minimal gates and checks. This is kind of the goal of what we're calling cloud native operations, is to get all of this infrastructure right out of the way and let developers just write the damn software. So cloud native operations is treating operations as a platform, as a product. It's taking lessons from cloud native software development techniques and architecture, and we reimagine how we're doing operations. Or we're playing catch up to what Netflix did 5 years ago. So where does Kubernetes fit in? So before we get specifically about that, I want to talk about controllers, which are kind of the secret to Kubernetes. Controllers are what elevates Kubernetes from just being a container scheduler into being a powerhouse platform. Effectively, Kubernetes stores the desired state of every resource that you request in etcd. Controllers form a control loop over that, and they act on the actual state of a resource to ensure that that matches your desired state. So it's effectively creating this fast feedback loop of autocorrective behaviors. They're based on the Unix philosophy of doing one thing and doing it well. So they're very simple, usually, and can be composed together to create more complex workflows and provide more value. Most resources that are managed by Kubernetes are actually managed by controllers under the hood, including pods. So in Kubernetes, pods are kind of the most basic resource for running a container, and they are actually incredibly fragile. They're scheduled to a specific node, and so their ability to survive relies on that underlying hardware to survive, which if you're up in the cloud, who knows, right? And that was done on purpose, because the idea was we were going to build these controllers to make them more resilient. And so there's a ReplicaSet controller, and that adds resiliency to your pods by ensuring a set number of replicas of your container is always running. So you have this control loop looking at your actual state and then looking at your desired state and making sure they match. In this case, I've asked for 3. It's going to make sure there's always 3. If there's less than 3, it will spin more up. If there's more than 3, it'll spin some down. Right? So it's constantly adjusting the actual state to match your desired state. And then that's extended again with a deployment controller, which adds more functionality and wraps around those replica sets to provide rolling upgrades of your software. So you don't really have to write any code or do anything special to get rolling upgrades of your software running when it's running in Kubernetes. The deployment controller works with replica sets, which works with pods, to do that for you. So all you're doing is changing your manifest to point to your new version of your container, and it's going to take care of that. So it's removing tons of toil from you by putting that smarts into the platform itself in the form of controllers. It's incredibly easy to write your own controllers to do simple things. It gets hard to do more complex things. And so you can create them to do things that are specific to your organization. By utilizing custom controllers, we actually turn Kubernetes into an API for doing operations, an API for reducing toil. And thinking of Kubernetes in this way helps you do cloud-native operations. So I'm going to quickly go through these examples. So we've all got these Jira tickets that ask for DNS changes. As an ops team, I worked for a large games company, and we would see like tens of these a day, right? And someone would go and either hand edit a bunch of bind zone files, or if we were lucky, that we had some chef recipes to do it for us. But it's still a lot of human work. Inside of Kubernetes, well, actually incubating, is this thing called the external DNS controller. And it watches Kubernetes resources, such as services and ingresses, and it looks at hints in annotations or other things in the spec, and will automatically go out and register DNS entries for the load balancer that's servicing that service. And then it will clean up when that resource is destroyed. So when I ask for a service, it automatically creates a DNS A record pointing at the IP address of the load balancer of that service. And it cleans it up, right? So just like that, I now will no longer have any tickets asking for DNS records to be changed because the platform has taken care of that for me. Another example, how many outages do we see because of a certificate failure? I have actually worked for a company that was on the 6 o'clock news for having an outage caused by a certificate failure, and we found out about it because someone was watching the news. So we weren't even monitoring for it, right? And that's not fun. I don't recommend doing that. So there's a certificate manager and controller in Kubernetes, although technically it's an operator, which we'll get to in a second. And it will create and manage Let's Encrypt certificates for your applications and store them inside of Kubernetes secrets so that you can either access them to set up your ingress controllers, or you can access them in your application itself to set up certificates for your TLS endpoints. So it's removing the toil around managing certificates. And when you tie those two things together, you get automatic DNS and TLS for any applications that are running on your cluster that need them. Operators take controllers one step further, and they allow you to create custom resources in Kubernetes that can be used by anybody in the cluster. So the canonical example is the etcd operator, which was brought to us by the CoreOS folks who kind of pioneered this idea of operators. And they allow anyone using Kubernetes to simply ask the Kubernetes API for a resource of type etcd with a spec of maybe like a size or a flavor, and that operator will build up an etcd cluster running inside of Kubernetes for them and will manage the lifecycle of that. CoreOS, now Red Hat, built out the operator SDK to make it fairly easy to write your own operators. And I've written one, so they can't be too hard. And many vendors are starting to write operators for their software. For example, Percona has an operator for Percona with extra DB replication, and it even has one for MongoDB. And they will, when you request one, it will stand up your database, it'll set up backups, it will set up the clustering and replication, it'll maintain, upgrade, and repair that cluster as sort of goes through its life cycle. I wrote an operator for GCP resources. So when I want an instance or a firewall from Google Cloud, I actually ask Kubernetes for it and let my operator actually coordinate that. So I had that single API for getting things out of Google Cloud as part of Kubernetes. And so it's controllers and operators that turn Kubernetes from being a container orchestrator to being that API for operations. You can make Kubernetes your control plane for like your entire data center, whether it's your physical or a virtual data center in the cloud. So time to run Kubernetes. So obviously we have to have the Kelsey Hightower tweets. So a lot of the people in the thought lords in the Kubernetes community talk about Kubernetes being a platform for building platforms. And that's great because in cloud native operations, we build platforms to support our developers. And so we want a platform that's built specifically for us to build platforms. And if you want to build a platform on top of Kubernetes, the last thing you really want to do is have to spend all of your time installing and managing Kubernetes. No one's really going to congratulate you from like installing and standing up a Kubernetes cluster, right? You haven't added any value until you're actually using that Kubernetes cluster. So you want to get to that as quickly as possible. So you want to use a service that operates Kubernetes for you, but still gives you access to enough knobs and buttons to make it work for you. Most of your public clouds, if you're in the public cloud, has a managed Kubernetes offering that is probably going to be better than one you can run yourself, unless you're already a Kubernetes expert, in which case they'll probably want to hire you. As you're building it out, you kind of want to make this decision whether you're going to have like one or two big clusters That's kind of the old school IT model of having a big platform, or you're going to have many small platforms, many small clusters, sorry. And I think the latter is probably the way to go. It kind of fits into that cloud native model a little bit better. But ultimately, you need to make that decision based on your org and where your org is at. But also try and remain flexible enough that if you decide that the other model is better, you could move on. And you may be constrained by which tools you're going to use, which model you pick, or you may choose the tools you want to use based on which model you want to pick, right? And PKS is up there 3 times. I work for a vendor. There's that. Either way, we've kind of got this decades of operation skills where we've learned how to run things on Linux very, very well. And we still need those skills. Kubernetes is a complex distributed system that's built to run other complex distributed systems. And so with that, you're still going to fight killer. You're still going to have network latency. You're going to still have too many open files because the defaults are still 1024. DNS issues, data corruption, all of that stuff. You're still going to deal with that. Just your interfaces into that is going to be a little bit different. This is a great link of horror stories of when Kubernetes has gone wrong and how people have fixed it. So I highly recommend going through that before you go too far down your journey of Kubernetes, because you'll probably learn a bunch. And I think starting with the idea of doing smaller clusters is the way to start off. If you hit a point where you feel one big cluster model is better for you, you can always look to consolidate things. But if nothing else, you're going to be limiting the blast radius when you screw up. And when you start doing Kubernetes, you're going to screw up a bunch. And so it's nice to know you've just screwed up one small cluster running one set of applications rather than the entire platform. And anything you learn from that screw up that's only affected that one cluster, you can apply that to all of the clusters. So you're not going to make that same mistake again across other workloads. But we're about building these pipelines. So removing the friction from getting code from source to production. So let's actually start filling it in. So first of all, you need Kubernetes. I'll use our product as a placeholder. That could just as easily be GKE or OpenShift or whatever. And you're going to run it somewhere. You're probably going to run it on a cloud. You may run it in your own data center. Either way, it doesn't matter. It's based on what you want. And Kubernetes runs containers, so you need a container registry. You may already have a tool like Artifactory or something that can do hosting Docker containers for you. Oh wait, I promised I wasn't going to say Docker containers. Linux containers. So you could use that. Or if you don't, I would recommend Harbor. It's in CNCF incubating. It's a great open source tool. And so as you pick tools to put into your pipeline, you're going to make decisions around if you're going to continue using a tool you have, or if you're going to put together a new tool that may be a bit more cloud native. So there's going to be trade-offs both ways. And the more things you decide to build new on top of Kubernetes is going to make it a bigger project, right? And so there's a lot of trade-offs to decide there. Regardless, your registry doesn't just need to support hosting images, but we have security, compliance, authentication concerns as well. So should it support external auth back to your LDAP or Active Directory? Image signing, vulnerability scanning, it should do all of those things. If it doesn't, at some point you're going to have to go back and implement those with some other tool because your security team is going to get mad at you. So it's better if you start with a container registry that supports most of those things to start with. You also need somewhere to store your source code. If you have to run it, you're probably going to run something in GitLab, but hopefully you're using GitHub or GitHub Enterprise and you're not worrying about managing it. You need somewhere to run tests and build your Docker images. So you probably have a bunch of Jenkins lying around and it's probably all really terrible. So it's a good opportunity to revisit and look at other tools. I've got Concourse up here, but Drone is excellent. And there's three or four other tools up in the CNCF landscape that are really good CI tools built specifically to work with Kubernetes. So we've got quite a few choices there. And then you need something to manage deployment into Kubernetes. Again, you've probably got some Jenkins. You can probably use that. But I really recommend looking into Spinnaker. It's a tool that came out of Netflix. And it's really designed with deploying software to a cloud-native way. So not just to Kubernetes, but its interfaces with Kubernetes is really good. And it's hyper-focused on continuous delivery, which makes it super useful to fill in that slot. So you now have a pipeline of tools that are going to work together to build out that CI/CD to take that code from deployment to production, right? So we're kind of enabling cloud-native operations by constructing this, this pipeline. And obviously, you can set gates and controls anywhere along here if you do need to have some sort of processes around restricting how quickly something goes to production, or if there needs to be some human work done before something goes to production. Every single one of these tools has a way to enforce that at the various spots. But our goal here is to remove that friction, not to add it back in. And as a platform team, you're also going to be building out all of the pieces for observability and other operations. So you'll use your existing tools, or you'll run new ones, hopefully inside of Kubernetes. I actually like the latter, even if it's the same set of tools. As a platform team, if you start using Kubernetes to run your own things, you're going to learn how to run stuff inside of Kubernetes, and you're going to be better at supporting your customers in Kubernetes, right? So whatever you can that makes sense, I highly recommend running it in Kubernetes, whether it's a separate like operations cluster that has a look over all your other clusters, or you're running a subset in each cluster. That's something you need to decide. So that's a lot of tooling and software that you, the platform teams, have to install and manage. And it's made worse because I am suggesting that you're going to stamp it out for every team and business unit. So that's kind of compounding the issue, right? And so this is going to start to become kind of a nightmare, or it could, right? Except we have spent 10 years or longer figuring out how to do Agile infrastructure, figuring out how to do the DevOps thing, right? And so practices like SRE and GitOps have emerged from the DevOps ecosystem. And they give us practical ways to implement some of this stuff. So there's a tool called Helm in the Kubernetes community. It's not perfect. There's a lot of concerns about Tiller, which are sort of founded, but also not really. Tiller kind of gets cluster admin in your cluster, and so a lot of people don't like that. But usually they're the same people that are emailing the credentials to each other for cluster admin over email. So your mileage may vary. But it gives you enough control to have that same set of deployment artifacts across each cluster, using Helm as the set of artifacts, and then you have environment files, Helm values files, as like the per environment description of what should be set where. And a lot of the work has been done for you with Helm. For all of the tools on that previous slide, there's a Helm chart up in the public Helm repository that will get you 95% of the way to building out that pipeline. And I'll show you that in a little bit. And so you combine Helm with that GitOps style workflow, and managing multiple clusters and all that infrastructure on those multiple clusters actually becomes only a bit more difficult than managing that single cluster itself. And so that's kind of your platform operations workflow. Your developer workflow, we've just built out a CI/CD pipeline for them, right? So they're probably doing something GitOps related as well. So they're working with Git, and it's running its way down the pipeline and eventually running in Kubernetes in production. By using controllers like external DNS and cert manager, we're kind of going to be helping them by automatically setting up all the extra resources they need outside of their application, even to the point of setting up, using like a MySQL operator to automatically set up a database, or to automatically go out and configure Amazon RDS for their application. So they're getting Kubernetes to do those things for you, so they have that sort of one deployment artifact. Now there is a lot more to it than I've sort of had time to talk about. So I'm going to do a little bit of a demo. I couldn't leave well enough alone, so I broke my demo environment. So I've got a video that I will play that covers most of the things I wanted to cover that we recorded for KubeCon. So before I do that, let me show you kind of the operator's view. We can see that, good. So I use a tool called Helm File, and that lets you compose a bunch of Helm resources together, right? And so here you can see I've requesting a bunch of Helm releases, so like my ingress controller, external DNS, cert manager, Grafana, Prometheus, Harbor, Spinnaker, Concourse, etc. And they all point to values files that are all pulled from Git. And so when I simply do Helm file, I'll just do a diff. That's kind of the GitOps deployment workflow of, has something changed? Do I need to do any work? Hopefully it'll say no. If it doesn't say no, then my tooling could then do a a Helm file apply, and it would apply the changes, right? So it's saying it's all good, I don't need to change anything. And if I do a Helm ls, you can see that I have a bunch of applications running that were all set up by Helm file. And so that is kind of my CI/CD pipeline. There's a few things missing there because I haven't finished setting it back up since I broke it. But you can see Spinnaker, you can see Harbor, Grafana, Prometheus, Xtotal DNS, etc. is all running in there. So now I will flick to this demo, which it has some audio recorded with it. So I figured instead of stumbling over it myself, I would just play it, and you can listen to the audio, and I can save my voice.
Hi. Today we're going to see a demo of using a PKS multi-cluster environment to build a continuous integration and continuous delivery pipeline with Concourse and Spinnaker. In this demo, what we'll have today is an application called Pet Clinic, built with Spring Boot and Maven. And where we're starting with the code is in a Git repository. Whenever there's a commit to the code, it's going to trigger a Concourse build. That Concourse build will start with a Spring Boot build of the application itself, test the application. If it passes all that, it builds a Docker image of the application and passes it to our Harbor container registry. Once it gets to Harbor, Harbor kicks off a vulnerability scan on the image to check for any security vulnerabilities. And then Spinnaker, which is our deployment tool, will watch Harbor for new copies of the application and then deploy them. So if the copy of the application is just a commit, it gets tagged with latest. And that runs into our dev cluster, which is a single node cluster, and it's ephemeral, so the data is just in memory for testing purposes. And then if it sees a full release version show up with a version number, it deploys it to production, which connects to a production database with persistent data behind it. This is running on 3 completely separate Kubernetes clusters provided by PKS. So if we take these clusters, you can see we have 3 clusters. So cluster 1 is where all these tools are running, and we have our dev and prod clusters. So if we go to our code here, let's make a change to the application. So we will go into the application and templates, that's that list. And here's a live application. You can see we're connected to the dev instance here. And this is what the application looks like. We can look up owners. We can see a list of veterinarians. What we see here, that just says veterinarians in the header. We want to add something to it. So we're going to modify it right here. This is it. So we're going to modify it right here in GitHub for demo purposes. But KubeCon 2018. And then let's commit that change. By committing that change, that will trigger the Concourse build to begin and build our dev environment copy. While that's building, what we'll do here is let's find an owner. We'll pick Betty Davis, and let's edit her and let's change her last name to Smith. So we can now see that her name is Betty Smith. So that way we will check on that after our new version runs. We can see if Betty Smith is still there, if it's back to Betty Davis. It should go back to Betty. So you can see the build is already started here. If we click on this, we can see it downloaded the code from GitHub. We can see that's the commit we're using. It's finishing the build. And we can see the stage here. It's compiling. And then now it's going to run the tests. So you can see it's running through all the Spring Boot tests that have been defined in the application. What happens when this is finished? We're going to have a jar file left that will get put into the Docker registry. So just a few more tests here. All right, let's create our jar file and package it up. And it's a success. Took a minute to build that. Now the next step is the Docker step. It's going to build us take that jar file and put it in our JDK image. So you can see we pull down the image. We're putting that jar file in it, saving it, and now we're uploading it to our Harbor registry. So it's been pushed. Now Concourse is actually going to download it immediately to make sure that it properly uploaded and it's readable and has the same hash. So we have it downloaded. We'll see, yep, success. So we have a green build, everything finished successfully. We go to Harbor and we refresh. Here's our app. See our latest. This is just a minute ago. We have the latest version. And if we come over to here, we can see it just kicked off the Docker registry in Spinnaker. So this is our dev environment, cluster dev. So it's deploying to development right now. So it's going to deploy a new one. And while it's doing that, if we look at our manifest, it's deploying one copy of our app, and we have it set to red black, which will disable our previous versions. So we'll always have two versions, the active one and then the last one, so we can always go back. So we can see that finished. So we can see the details of it. If we go to our clusters, our live ones, you can see we have a current version of that running. So if we go to our dev environment, so this should be our new copy. So first let's check our veterinarians. There's our new change to the application. If we go search for our owners, we'll see Betty Davis is no longer Betty Smith. She's back to Betty Davis. So that worked exactly as we expected. So we like that version. We think that worked out well. So let's promote that to a release. We've done all of our acceptance testing. So we're going to go back to our app here, and we're going to generate a release. And our last one is 0.1.6. So let's draft for the new release 0.1.7. We'll publish this release. So now that code is frozen at that point in time for production. So we come back to here. What we'll see in just a moment is this production build pipeline is only triggered on Git releases being added. So in this case, this was just a regular Git commit. In this case, it's specifically a release being added. While we wait for that to kick off, if we go into the production environment, so we can see it says Pet Clinic Prod here. We can see our veterinarian still has our old style there. Let's make a change though that is permanent, because we're using, this is a production environment. We have production data in it. So we'll add a new pet to Betty Davis. Call that pet KubeCon. And it's a hamster. Let's make a lizard. I think she's a hamster already. Yep. So now she has two pets, Basil the hamster and KubeCon the lizard. We're still running our old version. You can see here the production build has begun. Very similar to the last one. It's going to, the only difference here, it's actually grabbing a specific release that's tagged 1.7, and it's literally taking the release files. So you can see here it unzipped the source code that was tied to the release. So whether we build this release today or 6 months from now, we're always going to get this exact set of code. So it's running through all the tests, same as before. The main difference when this is done and it uploads, we're going to see a new version of Harbor that's 0.1.7. Just a few more tests here. And we should be just about ready to go. All right. Package our release, and we have a successful build. Same thing again on the Docker side. See a Docker app get created and push to the repo. In the meantime, you'll see here the difference in the production deployment options. We're actually creating 3 replicas, and we're connecting it to a live MySQL database. So that's how we know that it's in production. We're doing the same thing, red, black, just the current copy of 3, the 3-node version of the app, and the old ones are disabled. Again, we can roll this back. So if 1.7, we found some bug, the 1.6 versions are still running, and we can switch back to them. We'll see this should be just about done. It's pulling down the image to make sure it is matching the one that it uploaded, which we have a successful completion. As we refresh in here, we'd see 0.1.7, which we do, and here's our vulnerability scans. So if you want to see what this looks like, you can see we don't have any vulnerabilities. This scan happened very quickly. If we come over back to our pipelines, we'll see here our deploy to production is running. So we see the details. It's deploying that new manifest and then disabling the previous one. And we're all set. Green succeeded. We'll look here. We have take a minute for these to update and clear these out. In the meantime, I'll show you in here. This is what's our ingress, which we're presenting these apps to the public internet with these URLs. They're via a service. So these are the services that we are actively have them in here. So the prod service here, this is that replica set that we just deployed less than a minute ago. So you can see there's only one version of each being deployed, but we can see the previous version down here is still sitting there that we could switch back to. So 1.5 was running, and then 1.7. So if we go back to prod, let's take a look here. If we go to veterinarians, now we have our new list, veterinarians KubeCon 2019, and let's look up Betty. There's Betty Davis. and she has 2 pets, Basil and KubeCon. So our persistent data stayed on the back end because it's a production environment, but we're able to push our new versions of our app into production. As you see here, it's a very...
All right, we'll pause it there. So that's kind of what we're trying to get to. So we had we built out Kubernetes as a operations platform for us as a platform team to build a platform on top of focused at the developers. And so we used Helm to deploy all the infrastructure to do that. And then we have all that infrastructure, which by the way is all open source. Obviously Kubernetes is open source, but all those other tools are also open source. So anyone can grab these and build out this kind of pipeline. So thank you. That's it.
Peut-être quelques questions en anglais, bien sûr.
Hi. So thanks for the talk. So based on your experience, how hard is it to deploy Spinnaker, and how many resources how much?
So
what does it take to operate it?
So Spinnaker is harder to install than it is to operate it. There's a lot of settings based on where your code is, what kind of artifacts you're using. And so you're going to spend a lot of time up front setting up Spinnaker specifically for a particular team or application. But once it's actually running, it's fairly self-operating. So you kind of set up everything it's like a combination of your Helm YAML file for values and scripts and stuff to do all the Halyard config stuff that turns into Spinnaker config. So the front end of setting up Spinnaker is actually really difficult and frustrating. But the back end of Spinnaker, of actually getting that final delivery workflow, especially with it keeping a good inventory of your applications, handling the red flag deployment, etc., it makes that front-ended frustration worth it, in my opinion.
Okay, thanks.